Welcome to Books, Kids, and Creations, a part of the Authors on the Air Global Radio Network. I'm your host, Tracy Bloom, and I feature people who inspire future generations with their work. And today, you might recognize this face, maybe not, but she's been on before. Erin Winick is joining us from the JOIDES Resolution ship off the coast of Portugal. Holy moly, that's amazing.
Yes, thanks for having me. Excited to be here.
So first off, I'm very jealous of your weather right now because it's December, it's cold and dreary here in Ohio. You are on a board. Oh yeah, there we are. The beautiful ocean in the middle of is that the Mediterranean where you're at?
We're in the North Atlantic. We are going to go into the Mediterranean though in a few weeks.
Okay, okay. Yeah. So tell us a little bit about what you're doing out there.
Yeah, so the JOIDES Resolution is a drilling ship. When you hear that, you might think oil, but this is actually drilling for science. So this is taking rock samples from the bottom of the ocean and the ocean floor and bringing them up so the geologists can study them. And this expedition is Expedition 401. And so they have a specific science goal in mind, and they're studying a time when 4 to 8 million years ago, the Mediterranean largely dried up and lost a lot of water because the gateways, the paths that go from the Atlantic to the Mediterranean, were cut off. And so when that happened, a 1,500-meter thick layer of salt was formed in the Mediterranean. So this had big impacts for the oceans and the chemicals in the oceans and the different paths and the way the water moved. So these scientists are taking these big cores of the ocean floor, which we'll see some of the equipment in a little bit. I'll show you around of what's pulling these up. And they're going to use those to look back all those millions of years ago and try to solve those mysteries.
Wow, that's incredible. So I know you have, a science background, engineering background. How did you find this incredible job? Did it just kind of
Yeah,
present
so
itself, or?
so I've been working as a science communicator now for a number of years, which means I get to explain complicated science topics for the general public. And for this, I was looking at, leaving my job at NASA and trying to take on some opportunities that I could never do if I was working a full-time job. And this one came up. The JOIDES Resolution has 2 onboard outreach officers on every one of their expeditions. So we get to learn about the ship, train with the scientists, and then be able to do things like this and share it with you all, podcast classrooms, museums, so that the world can see this amazing work that they're doing, as well as doing social media. And I know it's important for you all, writing blog posts and updates and things like that online as well.
Yeah, I mean, I can only imagine that offering something like this, a tour that you're going to walk us through here shortly, to classrooms who might not ever see something like this or get to experience what you guys are doing. What a really, really cool initiative.
Yeah, absolutely. It's super cool. And they said, you're the first one for this expedition. So I've got plenty of classrooms and cool stuff later this week as well.
Yeah. And then how long are you going to be out there?
We're here for 2 months. So we don't go to shore at any time during those 2 months. So we have everything we need on board to live for that full time. So we've got lots of food stored down there, lots of fuel. But it's mainly because since we're a drilling ship, you have to sit in one place for a long time to get the drill down there, to drill as far as you need to. So we're going to be drilling in 3 or 4 locations likely that have been pre-selected and approved by the scientists. We know that they're safe and good places, and it should give them the information that they're looking for. And we'll spend, a week and a half-ish probably at each one.
Cool. I'm so excited to see this. So should we get moving? I feel like I'm right with you.
Absolutely. I'll tell you real quick here too, this map that I've been standing in front of. Feel free to walk through. All good. All these dots are places that have been drilled in the past. Oh. So these are all places cores have been taken throughout the history of not just the JOIDES, because that's part of a multiple decade scientific drilling program, but many other ships. And all of these cores, there are pieces of them now stored in repositories. So scientists are still using all this rock that's been taken for all these decades to solve new scientific problems. So with that, I'm going to take you all outside, and there might be some wind. We're going to start by seeing the lifeboats. I'm going to walk around the bridge and then kind of come to a stop near where the drill is. View that we have right now.
Oh.
It's absolutely incredible. And so I'm on the night or the day shift. So that means I actually work noon to midnight. So I get to see suns every day, but I do not get to see sunrises. So it's the sun getting a little lower in the sky. And what we see here is one of our lifeboats. These can fit up to 7, but we have 4 of them. So ideally we'll only have 35 people in each one in case of emergency. We actually just had a drill this morning for, we have one every week for making sure everyone knows how to stay safe on the ship and wear their life vests and all of that good stuff. I'm gonna walk around this. This is going to be the bridge of the ship. So the captain sits in there. I'm going to walk around the front and we'll see. It might be really windy. We'll find out. But behind me, a sneak preview. This is the large drill that we're going to see up close in a minute. That is around, it's a little under 200 feet tall. So it's pretty big.
Oh, wow.
All right. So here's the bridge of the ship. I don't know if you can see in, but this is, we have a navigation in there. They keep track of where we're going, make any adjustments. It's actually pretty calm right now. We've had some pretty big winds. We've been traveling at around 13 knots to be able to get to our location. In the distance there, you can probably see we actually have a number of ships around us too, because we're in a shipping lane. So we have lots of friends that we get to be able to say hi to. The ship itself is 470 feet long.
Wow.
So this is, and it's about 30 feet wide. This is like I said, just under 200 feet. And basically, the reason it needs to be so tall is they have to be able to set up the drilling pipe up here before it goes down to the bottom of the ocean. Actually, another interesting thing is you might think, how do you have a drill that's on a ship? It has to probably go through the bottom of the ship, right?
Yeah.
Well, there's actually something called a moon pool, which is a hole in the bottom of the ship that the drill can go through it. Think like, there's inner tubes. They can float, but they have a hole in the middle. It's that, but on a much larger scale. The hole itself is raised up from the water line, and the buoyancy of the ship allows there to be a hole at the bottom. And when there's extreme weather, we do have to, but it is a cool thing that we're able to do. Hopefully we'll be able to look through it at some point. We haven't really opened it up too much yet.
Right. I bet to look at that, it would be kind of unsettling because you'd be like, oh my God, there's a hole.
Yeah, apparently during the daytime, it actually can be a beautiful blue. Like it looks like you're just looking into a blue abyss. At nighttime, you see basically nothing. But all right, and then I'll show you now. So like I said, this drill is going to take rock from the ocean floor, but think, how does it do that? Well, over here we have a few drill bits. These are the things that go on the end. These are flipped upside down from the way they're sitting here. So this one would be if you're just trying to drill a straight hole with not pull the core out, which we don't want to do that. We want to make sure to get the rock out of the inside. And so that's why we have these holes in the middle. So these are 2 different types of drills. The one here on the left, might give me in it too. Nope. This one, you can shoot basically a piston core out of the middle. So think like a tube, think like a straw going into a milkshake. You shoot it straight down, and you put your finger on the top, and then you pull it out. That's what this thing is doing. So this thing will drill down, and it'll shoot about 10 meters out from it, like a straw, and then pull that core back up to the surface, which that's great for soft. When we have really hard rocks, we're going to have something in the middle that's instead going to be drilling it out, rotating, and trying to pull it up. So very different looking drills, right? Not like something you're used to at home.
Right. Yeah, and huge, naturally it would have to be.
Exactly. And then if you look up above me, that's what the core is going to be in. They're basically, like I said, big straws. And so when they come up to the surface, they're going to be inside these tubes. And then it's going to get laid out on this table here, where it's going to be divided into sections. Because imagine something that long is going to be kind of hard to bring inside, right?
Yeah.
And after they divide it into sections, we can take it into the labs. So that's where we can head next. Unless you have any questions so far, I can pause for a moment too.
No, this is really, really neat to see, especially how you pull it up, and the different drill bits. So do you operate the drills, or is there a different team that's operating those drills?
Yes, there is a different team that operates it. There's people that is their specialty. 24/7, they are constantly setting up, managing the drill, and then the scientists, they might come on the catwalk here to take some samples of the core, but most of the time they're going to be at the labs inside waiting for them to yell core on deck when it's up, and then it'll come out here. So
Cool. And so you guys have you pulled up any yet, or are you about to at your next place?
tomorrow, it's estimated around 6 a.m. our time is when we should be getting our first core. So
Okay.
everyone's very excited. Everyone's getting prepped in the labs and stuff. At last final training, learning about samples, all that sort of thing. So yeah, it's definitely a flurry of activity. Everyone being like, we're almost there. We're almost gonna get our rock.
Yeah, you know, and I can't help but like see the ties between your work that you did with NASA and this. I mean, do you see that any kind of like similar type of things taking place in space where we pull pieces of different planets or well, not stars, but planets?
Yeah. Well, on Mars, we're doing something similar, but on a much smaller scale. But yeah, absolutely. And I think one of the things that I've seen the most similarities with is because I work with the International Space Station a lot. It's a hugely international group. We have scientists from Morocco, Japan, China, the United States, Australia, Italy are all on this expedition together. And just like the space station, we're on a remote floating laboratory, isolated for 2 months with more people on board. We have around a little over 100 people on board when you count the scientists and technicians and people running the drill. And honestly, the people doing our laundry and our culinary, and like it's a huge team to be able to make this happen. So you're right. That's part of why I was so interested in this, because although space and rocks, not exact on Earth are the same thing, there's a lot of similarities that I could feel too.
Yeah. So
All right, you want to head into the lab? Yeah. All right, so we got another hefty door. All right, so the core has been divided into sections. The sections are now about 1.5 meters. First stop is the labeling. So we want to make sure that it's identified which core it is, where it came from. And then they get to sit on this rack for 4 to 5 hours because we want to get them to room temperature. Depending on where they came from and their depth, you can see they'll look similar to this once these are filled with core. And then after they sit, their room temperature, we can take measurements of them. It's consistent. They're going to come right around this corner into here, where it will be divided into halves. And so basically, we have two halves of the core. One that's the archive half, and one that's the working half. So what I mentioned at the beginning, we have a huge library of cores from around the world, from all the different places we've drilled in the past. That's because we've saved archive halves from those past expeditions as well. And in the working half, we are able to sample on board and study while we're here, so we can learn how many millions of years we've gone down in the rock already, and get those specific measurements that the scientists are looking for right then and now.
that's really neat. And I can't help but notice you put on a mask. Is there something around you in that environment that requires all of the PPE?
Well, actually, some of it I could take off now. It's funny. It's hard to carry the hat and everything like that. But no, we're actually just being careful to make sure everyone stays well on board, since we just got on just a little bit ago. So now that I'm around people and not outside, we're just making sure everyone stays good and doesn't affect, all the scientific work. You all are very aware of that world.
Yeah, we all are.
All right, so now we're going to go over and see there's two paths, because I mentioned there's now two halves of the core, which while I'm over here, I'll just show you real quick. There's two methods to be able to cut it. There's a saw in here, and this is like a cheese slicer, like those wires that you have. So if it's softer rock, you can use just a wire across there. Harder, you have to go to the saw to be able to cut it in half. And so now that we have our core halves, one will be coming over here, which this will be the working half, where scientists will take samples of it to be able to, like I said, take measurements on a lot of different things. So you'll see a bunch of instruments as we walk through here, and a bunch of these are the little sample containers that are a lot under here, all the different shapes that they need. And over here will be the archive half, where first they'll take visual measurements and record them, look at things like grain size. And then there's a bunch of different instruments over on this side, looking at things like density and actually taking photographs of it. You'll see a lot of microscopes around, a bunch of different tools and things that as us people who aren't familiar with geology wouldn't have a great appreciation of, but give us those hints and clues to the past by looking at everything from the water that's in the sample, the organisms that they're seeing, tiny little preserved fossils, and lots of different stuff like that.
And when the drill goes down, is there a camera with it as well so that you can see what's around the space?
Actually, there is one that can be sent down, but it's not there all the time. So the camera is sent down when they want to look at the hole or they need to re-enter the hole to line it up, but it's not always there. So a lot of people always want to see video of it. We don't have video that can go inside of the tube. We do have video that can go outside of the tube.
Okay.
So yeah, we'll get some of that, and sometimes we get some sea life and stuff like that that pops into view for little guest appearances as well.
Yeah, that's what I was wondering, basically around just around that depth that you're going, what kind of sea life you would normally be seeing.
I'm not sure for this part of the world. I believe the water depth is about 1,600 meters.
Okay.
So I don't know. I know that they've said that they've seen fish and squid and things like that in the past. We're not going into the deepest parts of the world's ocean where we can see land often from when we're sailing right here. So I'm not exactly sure. I'll let you know when I find out, when I start seeing little fish or whatever pop up.
Yes, I'd be very interested.
All right. And then just a quick look into here. We have all of our microscopes stored in. Some of our scientists are getting set up and waving. Here we have a scanning electron microscope and a bunch of different ones. So oftentimes they're going to be looking at nanofossils. So tiny little, basically what I would describe is if you could have a mini little dinosaur that's stored up inside of the rock. If they're single-celled organisms, so they are very, very small. Usually the max size you'll get is the size of like a grain of sand. So sometimes they're visual, sometimes they're not. But they're looking at tiny, tiny ones because they'll know when these animals lived. And so if we know when these species were alive, we can know how old the rock is. So that's a really important clue. And which ones were able to live at certain levels of salt, certain temperatures. So we get lots of clues about the ocean at the time from those different little animals.
Yeah. And once all of the data is collected, is there an additional span of time where you guys separately put together your findings, or how does that process work?
Yeah, great question. So some of the samples scientists are going to be able to take home with them now to afterwards. Other ones, a few months later, there's going to be what's known as a sampling party, where everyone gets together and is able to collect their additional samples. And then there's a few-year process where everyone works together to be able to publish results from the expedition. Science does take time, so it doesn't happen just like that. But there will be initial results like right near the end of the cruise because everyone's going to be actually writing their initial results while we're on the ship. So there's going to be some initial findings, and then they have that sampling party, a little bit more time, and then scientists from around the world can request these samples from these cores and this data as well. So it's not just the scientists who are sailing here that are going to be able to benefit from them. I'll show you one fun little thing here. This is our pet wall. So these are people's pets, and we all get to put them up. So we are out here for 2 months. So this is our little emotional support. These are my cats on the wall here. This is my fellow outreach officer, Kellen's cat, Moo. So we got some guinea pigs as well. And then these are actually all of the different expedition patches for past missions that have sailed on here. So we are Expedition 401. There have been a lot of different expeditions that have used this ship in the past, as well as I said, that legacy of different expeditions prior to this ship. We have a bunch of their logos too. Because while on board, everyone kind of designs a new patch and prints it on a t-shirt while we're here. So some of them are very fun and well-designed patches.
Wow, that's incredible. So how old is that ship?
So the ship was originally constructed in the 1970s. It was transferred into scientific work in 1984. We're taking a quick peek into the chem lab, which has a much easier handle to open. They have great music in here usually. All right. This is Erica, one of our scientists. Feel free. Go. So I'll show you a couple things in here. They have a big range of stuff. These are actually drill presses because what they're going to create from one of the samples is what's known as a squeeze cake. Yeah, don't let me get in your way. And so it's kind of a hockey puck size sample. They're squeezing water out of the sample, and they're able to do chemical tests on that water that comes out. So that way they can study a lot of different things, and even they can study the chemical makeup of these cores with spectrometers as well. So they're going to be using both the sample and the water that comes out of the sample in their chemical work.
That's really, really cool.
Yeah, and one other just fun fact is it's actually really hard to weigh things on a ship because the ship is moving. So they have scales, and it takes many minutes to actually get a weight reading on the stuff that they're putting on their scales. So you can't just hop on a scale and know how much you weigh when you're here.
Right. It's kind of nice.
Yeah, there you go. Yeah, we get some really good food while we're here too. So we get fed 3 meals a day on our shift plus 2 cookie breaks. So maybe I don't want to get on the scale. Like, yeah, you gotta get a little snack. So that's basically the shift. Downstairs, we have other like living spaces. So we have our movie room, and we have a lounge area, because although we are working 12-hour shifts, there you do have a little time outside of that to be able to relax for yourself. And we have the mess hall, as well as our living quarters, which are on the front part of the ship. We each bunk 2 to a room, so I'm bunking with the other person who's on the opposite 12-hour shift of me. So we still get some time to ourselves.
That's fine. Yeah. So so what kind of, I guess, what kind of things, like from the time that you get started in the morning, like what kind of things are you going to be responsible for collecting or studying?
Yeah, well, first of all, I'm excited because I am actually going to be able to help out in the labs some. So I am going to be able to learn from these scientists and just be an extra set of hands. I have a mechanical engineering background. It's not geology, is not my expertise, but I'm excited to learn that and then be able to document some of those processes to be able to share online. So my main work is going to be doing tours like you've seen for this one for a bunch of different types of groups. Making social media content. We had to each pitch a personal project for while we were on board. And mine was creating a bunch of short form vertical videos about the science first and foremost, but then the ship, the technology, and then the people, life on board. So that's going to be one of my focuses, which I'm super excited about. And I've already been sharing some. If you check out the JOIDES Resolution social media accounts, as well as my own, I'll be posting a ton there. And then doing writing, blog posts and updates about the expedition, the science, so we can share as we get it. And yeah, keeping basically the world up to date on the incredible things that these scientists are doing.
It's incredible. And I would imagine that, so do most people on board have a chemistry or a geology background? And so probably a wide variety of different types of backgrounds on the ship?
Yeah, you got it. And I think paleontology is another one because of those little fossils that I was talking about. Yeah. So people that are experts on these micro tiny fossils that you need to use those microscopes for. And then one of the other things I didn't mention when we were walking through is there's a group called PaleoMag, which if you don't know, the poles, our magnetic poles on the Earth actually switch every certain amount of time. It's very long periods of time. But these people are able to look at these cores and see when there's been a reversal in the magnetic polarity of these cores. And that again helps with dating and to learn more about these cores. So there's a whole group that is specifically specialized in that as well.
Wow. So once they complete their studies, they'll be able to see when the last time that happened was, I'm assuming, and then maybe when it'll happen again.
Yeah, and they're able to actually go back, because since we're going back 4 to 8 million years, there'll be a number of switches that happen in these rocks that we're getting up, because we're going down at most, I believe we're going for 1.7 kilometers.
Okay. Wow. So you guys
let me know if I need
you guys are going to find out all the things with your research. I mean, looking back that long into time, I'm sure there's going to be some really astounding finds.
Yeah, and like I said, this one is very focused on looking at this Messinian salinity crisis, this time when it largely dried up and there was a bunch of salt left at the bottom. So there's a lot of different elements that are associated with that. And the hope is to really learn about the impacts of this, because previous expeditions discovered that this happened. The goal of this one is to learn what really was the impact, and what we learned about that can also help us better understand our ocean and climate today.
I'm like just so excited that I got the chance to speak with you about this. And I'm excited to see what findings you guys conclude. So if guests, schools, museums, if they want to book tours just like this for their groups, they just go to the JOIDES Resolution website and they can book there.
Yes, and even if it's filled up for my expedition, there's going to be expeditions 402 and 403. So through the whole rest of this year, there should be opportunities for tours as well for you to get a chance and a look into the science.
So cool. So cool. And then once you guys are finished, are the results going to be public, or are they going to be typed up or put in a magazine, or where do those go?
Yeah, they will be public. So, as I mentioned, there's a lot of writing happening on the ship. So, there should be a publication that comes out towards the end of the expedition that has this initial results. And then, yeah, it'll be pitched to scientific journals. So, hopefully, it'll be published. All these scientists you've been seeing too have their own personal science projects on board.
Yeah.
So, not only is there this like big overarching goal, a lot of them have very specific goals within that. So, each of them are going to be publishing too. So, we'll try to make sure to keep you all updated on social media and the website when those all come out.
Awesome. Erin, I am like just so excited for you, and I'm really thankful that you took time to speak with me and our viewers, and what an amazing experience for you. Like, I hope that you just have the best time out there. I'm sure you will.
Thank you, and thank you for your interest in sharing what we're doing with the world. We really appreciate it.
Well, that I guess concludes this time that we're talking, but
Yeah,
I am just excited to every time I look at what you're doing, I'm just like, oh my gosh, what a cool path you're on. And I'm sure that viewers across the world can see that when you go into science, it's limitless for the things that you can get into. I mean, and explore and get jobs. And so what an incredible
yeah.
opportunity that you have right here. So that's amazing.
Thank you so much.
Yeah, thank you. And have fun out there. I'm sure that you will.
Thank you. Appreciate it.